Hello everyone, welcome back to Maxim Automation. In my last video, we discussed the concept of same origin policy, which says that a web browser should only permit scripts available in a web page to access the data of another web page when both the web pages have same origin. If the web pages are from different origins, then the scripts from one page cannot access the other page to read the sensitive data. Today, I'll discuss how the same origin policy is related to Selenium. As most of you guys already know, that to perform user action on a browser to run automation test, Selenium uses JavaScript to perform those operations or actions. Selenium injects its JavaScript into the browser, but as we know that, according to the same origin policy, we cannot run the JavaScript if it is not from the same origin. It means that Selenium cannot inject the JavaScript on a web page or application because Selenium core and web application are not from the same origin. Now the question here is how Selenium avoided the same origin policy, because we know that Selenium can run the JavaScript on any web application on almost every browser. So to avoid the same origin policy, Selenium used proxy injection method. In this method, Selenium server acts as a client-configured HTTP proxy, which sits between the browser and the application under test, and then it masks the application under test under a fictional URL. When we talk about the start of the Selenium, then it was first developed by Jason Huggins in 2004. He was working as an engineer in ThoughtWorks, and he was working on a web application that needs to be tested frequently. So he created a program in JavaScript to perform the user actions on the browser to test the web application. And initially, he named that program as JavaScript Test Runner. And he used that runner to test his application. Later, he realized the potential of the test runner, and then he made it as open source and renamed it to Selenium Core. So at first place, Selenium Core was created, which was basically the JavaScript library to perform the actions on the browser. But because of the same origin policy, there was the problem with Selenium Core. Because to run the Selenium Core scripts on a web application, user needs to install the Selenium Core and the application on the same machine, so that the domain or host name can be the same for both web application and Selenium Core. Because we know that according to same origin policy, we can run the JavaScript if it is originated from this same origin. But the problem with Selenium Core was that it requires a lot of effort to install Selenium Core and application every time on a new machine or in case of a new build. So to resolve this problem, Paul Hammond, another ThoughtWorks engineer, created a solution as Selenium Remote Control, or called as Selenium RC. So Selenium RC contains a server which acts as a HTTP proxy. And with the help of HTTP proxy, Selenium RC tricks the browser to believe that Selenium core program and the web application are from the same origin, so that the browser can allow the Selenium scripts to run on the web application. When we installed the Selenium RC, then it created a server on the machine. And then the job of the server was to create a HTTP proxy and inject into the browser. So the Selenium server sits between the browser and the application under test. And then it masks the application with a fictional URL, so that the browser understands the Selenium core and the application under test are from the same domain. Now the question here is, what is HTTP proxy and how does it work? A proxy refers to performing some actions on behalf of someone else. And a proxy server act as a gateway between user or browser and the internet. For example, let's say you browse your application on a web browser by providing an URL in the browser. So when you provide the URL, then at the same time, the browser sends a GET request to the actual server of the web application, where the application is hosted. But in case you have a proxy server configured, which sits between the browser and the application, then the browser sends the request to the HTTP proxy server instead of directly sending the request to the application server. When the proxy server receives the request from the browser, then it forwards the actual request to the application server. And because the application server received the request from the proxy server, so the application server returns the response to the proxy server only. If you don't have any HTTP proxy server, then the response from the application server will be received directly by the browser. But because of the proxy server, which sits between the application and the browser, then the response is received by a proxy server. And then the proxy server forwards the response back to the browser. Using proxies, we can change or add content within the data stream for various purposes. The same is the case when Selenium server creates a proxy server to change the response URL to a fictional URL, so that it can trick the browser to understand that Selenium core JavaScript and the application response are from the same origin. This is how HTTP proxy works. Now let's understand the Selenium RC architecture. Selenium RC consists of two things. First one is server, and the second one is the client library. Here the server is responsible for launching and killing browsers. It interprets the commands sent by the client library to perform the user actions. And then it runs the command on the application. It also acts as an HTTP proxy, intercepting and verifying HTTP messages passed between the browser and the application under test. And here, client libraries provide the interface between programming languages and the Selenium RC server. Selenium supports different programming languages like Java, C#, Ruby, Python, Perl, or PHP. Now let's have a look over this diagram. This is the architecture diagram provided by the Selenium on their documentation. You can see in this diagram, first, client libraries send commands to the server to perform the actions in the form of HTTP requests like GET or POST requests. Then the server interprets the command and sends the corresponding Selenium command to the browser using Selenium core JavaScript. The browser, using its JavaScript interpreter, executes the Selenium command. These JavaScripts perform the user action or assertions specified in the test script. Here, Selenium core is a JavaScript program which contains the set of JavaScript functions to perform the user actions using the browser inbuilt JavaScript interpreter. As we know that almost all browsers provide the default JavaScript engine to run the JavaScript. With the help of the same engine, it executes the JavaScript passed by the Selenium core. If we talk about these client libraries, then these libraries are available in different programming languages. These libraries provide the set of APIs to communicate with Selenium servers. These APIs are basically the set of functions which runs the Selenium commands. These libraries also receive the response for each command and send it back to the program or test script which we use to create. And based on these responses, we can mark our test as pass or fail. So this is the architecture of Selenium Remote Control or Selenium RC, and how it avoids the same origin policy by using the method of HTTP proxy server. In my next video, we'll discuss the architecture of Selenium WebDriver. I hope you like this video. Put your comments in the comment box. And also, please do not forget to like and subscribe to the channel. Thank you.